multi-wire circuit is a type of electrical circuit that employs two or more ungrounded or hot conductors along with a shared grounded neutral conductor. This configuration allows multiple circuits to effectively share the same neutral conductor, thereby reducing the overall number of wires required for the installation and simplifying the wiring process. When installing arc fault circuit interrupter or ground fault circuit interrupter receptacles on a multi-wire circuit, it is permissible to share the neutral conductor. The National Electrical Code, specifically Section 210.4b in the 2020 edition, explicitly states that on multi-wire branch circuits, the grounded neutral conductor shall be shared. This provision acknowledges the inherent design and functionality of multi-wire circuits, where the neutral conductor serves as a common return path for the current flowing through the ungrounded conductors. It is, however, crucially important to ensure that the neutral conductor is not interrupted at any point within the circuit. This is because AFCI and GFCI devices critically rely on the integrity and continuity of the neutral conductor to function correctly and provide the intended safety features. An interruption in the neutral conductor can lead to a dangerous imbalance in current flow, potentially causing nuisance tripping of the AFCI or GFCI device, or worse, rendering it ineffective in detecting and mitigating electrical faults. Therefore, it is absolutely essential to connect the neutral conductors of all the receptacles installed on the multi-wire circuit to the same neutral bar or bus within the electrical panel. This connection point serves as a central hub for the neutral conductors, ensuring that they are electrically common and that current can flow freely and safely back to the source. Proper connection to the neutral bar or bus guarantees the correct operation of the AFCI and GFCI devices, providing the necessary protection against arc faults and ground faults, which can lead to electrical fires and shocks. The importance of maintaining a continuous and uninterrupted neutral conductor in multi-wire circuits with AFCI and GFCI protection cannot be overstated, as it is fundamental to the safety and reliability of the electrical system. Firstly, understanding the fundamental principle of a multi-wire branch circuit is essential. A multi-wire branch circuit, often referred to as an MWBC, consists of two or more ungrounded conductors that have a voltage between them, and a grounded conductor that has equal voltage between it and each ungrounded conductor. For instance, in a typical 120 volts or 240 volts system, two ungrounded conductors each providing 120 volts to neutral are used. The key here is that the neutral conductor carries only the unbalanced load, which is the difference in current between the two hot legs. Secondly, the sharing of the neutral is permitted because of this characteristic. If the loads on each of the ungrounded conductors are perfectly balanced, theoretically, there would be no current flowing through the neutral conductor. In reality, loads are never perfectly balanced, but the neutral still only carries the difference. This is why the National Electrical Code allows the neutral to be shared as long as certain conditions are met to ensure safety and proper operation. Thirdly, NEC Section 210.4b specifically addresses the requirements for multi-wire branch circuits. It mandates that the grounded neutral conductor shall be shared. This is not merely a suggestion, but a requirement, assuming that the circuit meets all other applicable requirements. It is important to note that while the NEC permits sharing the neutral, it also places certain restrictions and requirements to prevent overloading and ensure safety. Fourthly, when using AFCI or GFCI receptacles, the shared neutral becomes even more critical for proper operation. AFCI receptacles are designed to detect arc faults, which are dangerous electrical discharges caused by damaged or deteriorated wiring. GFCI receptacles, on the other hand, are designed to detect ground faults, which occur when current leaks to ground through an unintended path. Both types of receptacles rely on monitoring the current balance between the ungrounded and grounded conductors. Fifthly, an uninterrupted neutral is vital for AFCI and GFCI functionality. If the neutral conductor is broken or disconnected, the AFCI or GFCI receptacle may not be able to accurately detect imbalances in current flow. This can render the receptacle ineffective in protecting against arc faults or ground faults, potentially leading to electrical fires or shocks. Therefore, it is absolutely essential to ensure that the neutral conductor is continuous and properly connected throughout the entire multi-wire circuit. Sixthly, proper connections in the electrical panel are paramount. The neutral conductors of all the receptacles on the multi-wire circuit must be connected to the same neutral bar or bus in the electrical panel. This ensures that all the neutral conductors are electrically common and that current can flow freely and safely back to the source. Loose or corroded connections can create resistance, which can impede current flow and cause voltage drops. This, in turn, can affect the performance of the AFCI and GFCI receptacles and potentially lead to nuisance tripping or failure to operate when needed. Seventhly, consider the implications of an open neutral. If the neutral conductor in a multi-wire circuit becomes open, the voltage on the two ungrounded conductors can become unbalanced. This can result in some devices receiving a higher voltage than they are designed for, while others receive a lower voltage. This can damage or destroy sensitive electronic equipment and create a safety hazard. AFCI and GFCI receptacles may not function properly under these conditions, further increasing the risk of electrical fires or shocks. Eighthly, to avoid problems, follow best practices during installation. This includes using appropriately sized conductors, making sure all connections are tight and secure, and testing the circuit after installation to verify that it is working correctly. It is also important to label the circuit clearly to identify it as a multi-wire circuit, so that future electricians or homeowners are aware of the shared neutral and can avoid inadvertently disconnecting it. Ninthly, keep in mind local codes and amendments. While the NEC provides a baseline for electrical safety, local jurisdictions may have their own codes and amendments that are more stringent or specific to local conditions. It is important to check with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. Tenthly, regularly inspect and maintain the electrical system. Over time, connections can loosen, wires can become damaged, and receptacles can wear out. Regular inspections can help identify potential problems before they become serious hazards. Any damaged or worn components should be replaced promptly. AFCI and GFCI receptacles should be tested periodically to ensure that they are still functioning correctly.